density function, this is exactly what the dnorm function does. The density normal function exactly calculates the probability density at different values of x for different normal distributions. So I want to compare how I just defined my density function to how the built-in dnorm function works in R. And I'm going to do this using the vector of values that I stored in birth weight, which came from this random variable x, which had a normal distribution with mean 3,500 and standard deviation 600. So unless you've defined birth weight, if you define this birth weight vector, great, this will all work. If you haven't run the previous code cells, you're going to get a crash if you haven't stored anything in birth weight. So we did this in question 1C. So you might just want to go back if you just opened up this notebook and run the solution in question 1C over here. So here I've stored stuff in birth weight. I've set the seed, so I've got this consistent output. It's not important if you've set the seed. You can generate any old stuff that you want in birth weight. You don't have to have the same vector that I have up here. But you need to have something in birth weight. And so now if I want to use my density function, I've got three inputs that I need to enter. First is my vector of values, my x. So my vector of values is stored in birth weight. Next would be the value for mu, which is the mean 3,500. And then would be the value for sigma, which is 600. And I get all these outputs here. So it's running. I'm getting output. That's great. At least nothing crashed. I have no idea whether that is right or wrong. But let's compare it with the dnorm function. So the dnorm function would work much the same way. We first enter x. In the dnorm function, these aren't called mu and sigma. They're called mean and SD. So these inputs have different names. So I just want to make sure that I give them the right syntax. But otherwise, it's going to work like this. And this might hurt your eyes to compare these, but seems like they're matching up. This is a bit difficult, but I think if you look at this, it seems like they are matching up. Perhaps a nice way of testing this out would be to say, let's like store this stuff to the stuff in the first code cell to a vector A. Let's store the stuff in the second code cell to a vector B. We'll still print it out to the screen. And now let me take the difference in these two vectors, and hopefully we get zeros. And you can see we are getting, for the most part, zeros. Seems like, oh man, we're getting like things that aren't zero. But if you look at this, this is like a value, and this is like e to the minus 20th. So this is like scientific notation. So this is like times 10 to the minus 20. So this is like 0.0000000000000000271, blah, 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 right? So this is essentially zero. This is just like due to rounding error in how we defined our function compared to how whomever originally wrote the script for the dnorm function. So somebody has some rounding error in one of these functions, but they're equal to each other out to 21 decimal places. So that is essentially zero. The my density function that we wrote is giving us the same values as the dnorm function is, at least out to like 21 decimal places. So that's a great job. Our density function is doing the same. I'm convinced that we've got accurate calculations. We've coded our density function just fine. Okay, so I'll stop this video here, and one last video to go along with this Colab notebook, which is how to write a function that returns not just a single calculation, but like how do we write a function that returns like summary output. So I have a vector, and let's say I want to get not just the mean, but I want to get the mean, the standard deviation, the median, and like several bits of information all output at once. So that's what we'll talk about in the last video for this notebook. Thanks.